Hello. Today we're going to be looking at different function types. And so I have a list here of 7 different types of functions we're going to focus on. My suggestion is follow along and in your notes write the different equations and make perhaps a rough sketch of what a graph of one of these would look like. So let's start with a constant function. So a constant function, we'll just start with f of x. Constant functions always equal to a number. So f of x equals 4, or f of x equals -3. Okay, it just makes a horizontal line. Notice, remember, f of x is always the same thing as y, so my y values on this line are all 4. My y values on this line are all -3. So that's what a constant function looks like. A linear function, delete that one. So a linear function, these should look pretty familiar. These are going to be your y equals mx plus b type things. So 3x plus 1. We have a slope of 3 in this case and a y-intercept of 1. And I'll clear these out, make it a little easier to see. So it makes because it's linear, it makes a line. And f of x, again, being y, f of x needing to be by itself, they're always just going to take the y equals mx plus b approach. So minus 5, something like that. Okay, both of those are linear functions. How about a quadratic? In a quadratic function, we always have that x squared piece. And you can see right away there's your parabola, the shape that a quadratic takes. And I can add some unique things here to this. There's a quadratic right there. Or we can go as simple as, say, f of x equals x squared minus 2. Okay, both of those are quadratic. They have that x squared piece, and they're going to make a parabolic shape. Okay, exponential. In an exponential function, you take your number as a base, and then you raise it to an exponential power. Again, I'll clear these out and make it easier to see. And notice that as you read left to right, it hugs the x-axis until it grows very, very quickly. Now, this isn't the only way we have to write those. If you remember, we can do fractional things. So I'll do 1/2 to the x power. And so these decay quickly and then start to hug the x-axis from there. Okay, piecewise functions are the functions we just discussed in your notes from last night. So f of x equals, and this is going to look pretty unique, different from the way you might be used to. So let's say for x is greater than 0, we will say cosine of x, and for x is less than 2, we'll say we'll just output 4. So that's what this piecewise looks like. Notice that over here, we need less than -2. That makes more sense. There we go. So all of my x is greater than 0, output this cosine function. X is less than -2, output just the number -4. Absolute value, these have the absolute value symbols to them. And I can't type those. I use ABS for absolute value, but you're pretty familiar, I'm sure, with what they look like. They're going to take on the V shape when all is said and done. But I can add and subtract numbers on the outside of it. I can add and subtract numbers on the inside of it, etc., etc. Okay, a square root function does what it sounds like. A square root function contains a square root. move it around by playing with some of these numbers. Let's do a -5 instead so you can see it. So that's kind of what a square root function looks like. I do want to talk about one more that I just kind of recalled as I made that piecewise function, a trigonometric function here. Trigonometric functions contain exactly what you might think, one of the trig functions. So like sine of x. I did sine of x plus 2 to move it up, or sine of x minus 3, then plus 2, and so on. Okay, it doesn't have to be sine. It can be cosecant. It can be cotangent. It can just be regular tangent.